Hello everyone, my name is Stephen Burns and I'm a geophysicist with Geometrics. I'm in the seismic sales group. I'm also in the mag sales group, specifically working with the MagArrow. And today I'm going to answer some common questions people have on the MagArrow magnetometer. So I'm just going to run through these. It's going to be a quick video. I highly recommend that you watch it if you own a MagArrow or you're thinking about purchasing a MagArrow, or even if you're just interested in UAV magnetometry in general. Some of these questions apply to the broader survey methodology. So let's just jump right into it. First question is, what's the max wind speed for the MagArrow? And when you're flying a UAV, the max wind speed that you'll probably fly at is 15 miles per hour. Beyond 15 miles per hour, I don't think any sensible UAV operator is flying in those conditions. So 15 miles per hour would be the max wind speed, though ideally it's no more than like 5 or 8 miles per hour. I mean, really, in a perfect situation, there's no wind, right? Or it's negligible. But with the wind speeds at 5 to 8, seems to be fine, especially if the UAV and the MagArrow are clipping along at 7 meters per second, 10 meters per second. The MagArrow's aerodynamic profile keeps it really locked in and stable on that flight path, and the wind won't affect it much. Now, if you do have some winds that are greater than 5 miles per hour, then what you can do is you can plan your survey to get the MagArrow and the survey lines oriented parallel to the wind. So that way, rather than the wind buffeting the MagArrow from the side, you're now flying into the wind. Or you have a tailwind. So those are some things that you can do to help if you do have wind during your survey and you still want to get your data collected. So 5 to 8 miles per hour is probably like the realistic upper range I would give, but push comes to shove, and if you're flying into the wind or you have that tailwind, up to 12 or 15 or so. One important thing is, which the MagArrow doesn't suffer from this problem, but it's still important to be aware of, is the swing of the sensor. The MagArrow has 2 orthogonal sensors that actually put out one data reading, and we have a specialized algorithm that combines the signals from both. And the reason we did this is it creates a magnetometer which has no dead zone. So it doesn't matter which direction you're flying, you won't encounter any dead zones with the MagArrow. You won't have any data dropouts based off of where you are on the globe and declination of the magnetic field and inclination and things of these nature. So that's important because on a swing, when you're turning and you're doing a UAV mag survey and the sensor swings, or maybe the wind pushes it and it swings, some sensors will swing into a dead zone and therefore your data will drop out. MagArrow doesn't have that problem. So even if it's being buffeted by wind in that unfortunate circumstance, you won't have any dropouts in your data. You won't encounter any dead zones. And that's probably the biggest problem that's encountered when the wind speeds go up. So what's the ideal? The second question would be, what's the ideal pattern spacing for a survey? And this is both like flight altitude and then also line separation. And typically the recommendation I give is that you fly a 1-to-1 ratio. So if you're flying 10 meters above ground, then you should have a line spacing of about 10 meters. If you're flying 50 meters above ground, then a line spacing of 50 meters. Now, this depends on what type of object you're looking for. That's really the determining factor for your altitude and for your line spacing. Depending on how big you expect that anomaly to be and the nanotesla variation for that will determine, and of course, like the actual physical size and shape and the induced magnetization, and some of those factors can give you a suspected anomaly size. So that will really determine your altitude and spacing. But if you really want to keep it simple and you have a rough idea of what you're looking for and it doesn't need to be too precise, then like a 1-to-1 ratio is really good. So for example, you're looking for buried wellheads, legacy oil and gas infrastructure, and you're flying at 30 meters above ground, well, then your line spacing would be 30 meters. And that works out pretty well for most circumstances. So 1-to-1 ratio works really well. Any options besides Wi-Fi to download data? So the MagArrow, you pull data off the MagArrow using Wi-Fi. And there is one other option, and that's a very, very last resort. The MagArrow has an SD card inside of it, and that's what it writes all the data to. And in the event of like the really unfortunate event of like a crash or something, you can always recover your data from the SD card because it's writing to it. I think it's like every second or so. So the issue though is that the data on the SD card is not formatted properly. When you go through MagArrow.net, which is how you interface with the MagArrow, right? First you connect to the MagArrow, you connect to the Wi-Fi network, go on your browser on either your phone or tablet or computer. We recommend like a laptop using just Internet Explorer or Edge, Chrome. Then you can type in MagArrow.net, you'll connect to the MagArrow, and from there you can start your survey and you can start your acquisition and pause and download and all this stuff. So that's the primary way to go through it. And when you download data for the MagArrow through that format, through that interface, it'll be formatted properly into a .dat file, which then you can convert into ASCII2 or a GeoSoft GDB. But on the SD card, it's a preliminary file format. So you'll have to talk to our engineering team, and it's just better you avoid that. So downloading data basically is done via Wi-Fi. And a couple tips on downloading the data. The MagArrow has a battery life of 2 hours. So you can fly around, zip around. 2 hours later, your battery life it's near the end. So I recommend that you probably do a battery hot swap on the MagArrow every 90 minutes. Or maybe it's every 60 minutes. Because those little batteries are really easy to charge. It's not hard to charge them up. So err on the side of caution, and you could hot swap them every 60 minutes. When you hot swap the batteries, the MagArrow operation doesn't turn off. So that's really nice. You can pause your data acquisition, or you can just keep collecting the data and it won't interrupt the functions of the MagArrow at all. So I recommend when you land the MagArrow, let's say it's been 60 minutes and you have a hybrid gas-electric drone that can fly for a long time, like a perimeter array from Skyfront. Let's say you land after 60 minutes or 90 minutes. I recommend that you do your hot swap, and I would also recommend at that time that you download your data set. So let's say it's acquisition 1, ACQU1. You could pause that acquisition, and then you can download it. And then when you're downloading it, it'll just download as acquisition1.dat. So what I would recommend is, first off, keep really good field notes. And second, I would rename that to be, let's say, like flight block 1, lines 1 through 12, and leave the .dat. And now you have a really clear record of what flight block that is and what lines you flew. And if it goes back up and flies for another 90 minutes and lands down, and now you have the second half of your flight block, then you could either A, download the full data set if you're complete for the day, or if it's still an intermediate step, then you type in flight block 1 and then lines X through X, and you could keep kind of leapfrogging along this way. The MagArrow will keep writing data the whole time. So you could just let it run and collect data the full 8 hours, though that doesn't really, you have a higher risk of just anything happening with that. So I really recommend that you do these intermediate data downloads. And again, write them out, flight block, line numbers. And then at the end of the day, if nothing happened, which is typical, it's very rare for these things to either crash or malfunction. Then at that point, you could stop your acquisition and download the full data set uninterrupted, and that will make it really easy to process. Let's say like 100 megabyte data file will take like 5 to 8 minutes to download, so it's really quick. It's really not a big chunk of time, and you'll find that you'll still be doing your other drone operations, your safety checks, maybe you're grabbing a drink of water or something like this while that's happening. So it doesn't really interfere with like flight planning and surveying out in the field and being efficient with your time. So you download data via Wi-Fi, make sure you keep good field notes. When you download those intermediate data files, write out the block number and the line. You don't have to change out the battery as often if you're flying something with a shorter battery life, like just a pure electronic drone. Let's say you're flying a M600 from DJI or an M300 or 210, or there's all these drones out there. Let's say you're flying one of those and the flight time is 20 minutes. You don't have to hot swap for every shorter flight. You have a 2-hour battery life. Maybe you do it every 3 blocks or every 4 blocks or every 4 takeoffs and landings. But I would still recommend that you pause that data, extract that data, download it, and then write out the details as explained before. So that's just some best practices that I recommend. It's definitely going to save you time and reduce your risk in the field. Talking about data, is there any way to confirm that data is being collected while in flight? So the primary way that you confirm and do a QC check on the MagArrow is you start your acquisition, and right when you hit start, it's now sampling at 1,000 times per second. And if you're on MagArrow.net, you just let the browser sit there. Don't fly off of the MagArrow. You should just be either just hovering or on the ground, and then hit refresh, maybe like 10 seconds later. And when you hit refresh, it'll reload, and you should now see that acquisition has some sort of kilobyte value to it. So that means it's recording. If it was at 0 kilobytes to start, and now it's at 4,000 kilobytes, now you've collected some data. So you can be confident that you're collecting magnetic data. So that's your first QC check. When it's actually in flight, let's say a mile and a half away or way off there, there's no way to check that it's collecting data. The MagArrow Wi-Fi connection, I don't recommend connecting to the MagArrow when it's not immediately next to you, or let's say hovering right next to you. The MagArrow.net interface isn't perfect, so it's definitely recommended you're within 20 feet of the thing. So don't attempt to try to connect to the MagArrow as it's flying close and then looping and going away again. That's just a recipe to cause everything to time out. You're going to have to airplane mode your device, reset the cellular connection, reset the Wi-Fi connection, and connect to it again when it lands. It's easier just not to do that. So when you're in flight, you've already done your QC check, the fact that the data is collecting, so you know it's good. Don't worry about it in flight. The one thing you can do is if you're flying at night, or perhaps it's not the brightest out, the MagArrow has status indicator LEDs on the bottom. And if those are flashing a certain pattern, then you know it's in use, the status is good, and it's collecting data. So you can look at those flashing LEDs. They're very visible, and they're going to be extremely visible at night. So that leads into the next question. Are there any issues flying at night? And as long as you get FAA approval, there's no issues flying at night. If you're doing any sort of close terrain following, I just don't recommend it. Or like make sure you have good elevation data if you're doing anything that requires changing altitudes, changing of AGLs, above ground levels in flight. But yeah, if you get FAA approval, there's no problem flying the MagArrow at night. Actually, those LEDs will be more visible at night. So maybe it gives you peace of mind that you'll be able to see those status lights a little further out. But again, the MagArrow operation is really reliable. So if you do that QC check at the beginning and see that the file is actively writing down data and it's increasing in size, then you know you're good. The rental MagArrow. So we sell the MagArrow and we also rent the MagArrow. If you want to try the MagArrow for rental, then you can do that. We have a rental department, and we rent to export controlled and non-export controlled countries. The export controlled countries, we will rent to a MagArrow-SX, which is a lower sensitivity version. Still perfectly fine for things like mineral exploration and wellhead locating, but there are some USA export control requirements in place. I'm not going to get into them. If you're interested in renting, send an email to rentals@geometrics.com. That's rentals@geometrics.com. And just let us know the country that you're renting from, and we'll be able to let you know whether you're in an export or non-export controlled country. But we have both options. And the MagArrow comes with the Survey Manager software, which is what you use to convert the raw data into a ASCII2 file or directly into a GeoSoft GDB file. And it also comes with suspension cords, 3-meter suspension cords. So you don't have to worry about your rigging. We find that when the MagArrow is suspended below a drone about 3 meters, there's really no magnetic interference to worry about. And if you are worried about magnetic interference from the UAV, and you also want to do some heading air correction, then what you can do is you can fly up 100 meters with your drone, do 2 or 3 really slow 360s to get really a lot of data through all the different azimuths. And then you can apply a heading air correction. Either you can code that yourself or use GeoSoft, or there's a few options out there. So that's recommended. Though it's not necessary, it improves the data slightly, but most people in their surveying find that the heading air with the MagArrow is pretty negligible. So it's nice. You can just take your MagArrow, connect it to the drone via these suspension cables. Zip ties and electrical tape are your best friend for MagArrow surveys, so bring those and bring a lot of them. You can connect the suspension cables to the connection points on the MagArrow, or you can put some crossbars on the bottom of the MagArrow and widen that attachment base. In my experience flying the MagArrow a couple times now with those crossbars, it definitely flies better. It's a more stable flight, specifically on the turns. It's just more stable in flight when you're doing those draping turns, or even a direct 90-degree turn and then another 90-degree. Even we've actually tested 180 and 270-degree turns, and they were much more stable with those crossbars that are about 2 feet long. So you have multiple attachment options for the MagArrow, and then with the drone, you just take those cables and find something to zip tie them onto. With an M600, it's really easy to zip tie and electrical tape those cables onto the arms of the drone. And for a perimeter, you can zip tie them to the 4 legs of the drone. Other drones, you have to do that testing yourself. We haven't tested every drone out there, but for the most part, it's really easy to either attach them to the legs or the arms, and the cables are they're non-magnetic, so they don't interfere with the data quality of the drone, and they're all built to the exact same length, so you're not going to have to deal with any differences in lopsidedness and things of this nature. So there's some general information for you about the MagArrow rental. You're also given a screwdriver. We do not send any batteries. So the batteries are difficult to ship. There's all these regulations around shipping batteries, so you have to source the batteries yourself. But I'll put a link in the description of this video to the batteries that we recommend, and they're really cheap. They're like 20 bucks. I recommend you buy a few of them and get a battery charger, and just make sure you charge your batteries either every night or in the field, and you'll have no problems. So if you have any other MagArrow questions or UAV mag flight operation questions, anything at all that's related to this topic, please share them in the comments below, and I can make a follow-up video addressing those questions you have or possible concerns that you might have about this relatively new geophysical technique. It's been really exciting here at Geometrics building out this field of UAV magnetometry, because it's been around for a while, but we are one of the leaders, and we came out with one of the first UAV magnetometers, the first one that weighs less than a kilogram. It's very, very lightweight, and it's been really, really incredible seeing how different universities and research organizations and service groups have all adapted the MagArrow to the problems that their clients face, and then have provided really elegant and beautiful solutions as a result. So UAV magnetometry has definitely revolutionized the field of magnetics, and it's in many ways, compared to a land survey or an aerial survey, it is a far superior solution. So we hope that if you're new to UAV magnetometry, you give it a try, either with a rental, or maybe you just go in and purchase one and build up the clientele. And if you're already doing it, hats off to you. Thank you so much. We hope you enjoy the use of the MagArrow, and stay tuned for updates. You can follow us on LinkedIn. I'll put a link to that below. And you can also subscribe to our YouTube channel where we release more FAQ videos or different kind of like docu-series, webinars, software training. I highly recommend you subscribe to our YouTube channel to stay up to date with everything geometrics. So again, my name is Stefan Burns. I'm a geophysicist with Geometrics, and thank you all so much for watching. Have a great day. Ciao.